not connected. And because of this, our particles in event 1 are not actually actuated. In other words, they're not birthed, given a position, and then displayed. So let's remedy that. I'll select the little wire that appears at the bottom of the global event, and I'll drag it over to the loop on the top of event 1. You'll notice as I drag that a wire is shown. And when my cursor is over the top of the loop on event 1, it changes to an inward pointing arrow, and this indicates that a valid wire target has been found. So I can leave go here and particle flow will wire the two events together. Okay, there we go. Now if I move the viewport over here a little bit, you can see we've actually got some particles. So that's cool, we've actually made our first very basic particle flow. Now one thing you might have noticed that when I wired the two events together, in this case the wire is, you can see it's dynamic. I can drag this event around and you can see it's produced a dotted line. Now this is only the case with connections between your source event and your first event, whereas if you used a test and you connected two events together, the line wouldn't be dotted, it would actually be a solid line. So the dotted line is only actually used for, as I said, connections between your source event and your first event. Now if we look in the viewport, you can see that if I scrub the timeline, you can see the particles are appearing and they're not really doing anything else, are they? They're just sort of sitting there on the icon. That's because they haven't got any speed value assigned to them, and when I assign a speed value to them, it'll create a new channel on the particles, and the particles then will have a speed value, and it can use that to actually define which direction it's going to travel in. So I'm going to do that by using a speed by icon operator, and I'll just find it here. There's the speed by icon. So I'll just grab that and we'll just pop that after the position icon. Actually, it's not speed by icon. Sorry, I'll just delete that. We're looking for speed. There we go. Just pop that in. Speed by icon is actually used for a different purpose where the icon controls the particles over time. Whereas the speed icon is a lot more simple, and it's generally the one that you'll be working with most of the time. So if we have a look at its parameters, you can see that its direction is currently set to a long icon arrow, and what this does is it actually uses the arrow, which you can see coming out of our icon here, and it uses that for its direction of travel. So if we scrub through the timeline, you can see that we now have particles flying out. They've got a speed channel assigned to them, and they're using that, and they're traveling off through space. So that's pretty cool. We've now got an emitter, we've got some particles being birthed, and you can see that they've been given some speed. And if we just deselect, you can see that they're using the display operator as we set up before. It's got purple ticks coming out of it. So you can see we have a very basic flow now, but there's no real flow from event to event. We only have one event really, well, two events, the source event, but that's not really used for particles in general. So we need another event that we can then flow the particles to using a test. So I'll do that by creating another speed operator, and I'll just drag that out into the viewport and drop it. And you can see it's created a new event, and it's called event 2, which is pretty understandable. And it's created a new speed operator called speed 2. We have speed 1 here, and we've now got speed 2. And it's created a new display operator, and it's called it display 2. So it's, you can pretty much detect a pattern there. And it's using the same values as in the first one, so that wouldn't be very desirable. So what I'm going to do is I'm going to change the parameters on display 2, and I'm going to change the color to a dark red, and I'm going to change the look of the particles to let's just pick this as diamonds. So if I scrub the viewport now, you can see the particles fly out. They're flying out very, very quickly, and they're just flying off through space at a constant rate. I mean, if we go to the end of the timeline and look down, actually let's drag it back up and drag down. Okay, there we go. We can see the particles have flown off in this direction. They've gone all the way down here. It's not a very interesting animation, is it? So anyway, one thing is that they're moving very quickly, so I'll just go to speed here and change the speed to 50. So they now travel at a much more sedate rate. I'll just pop them up the top of the screen here, and you can see that if I scrub now, you can see they come out at a much slower rate. They're still not slow, but they're definitely going at a slower rate. Now, what we want to do is create some kind of flow. As I said, we've got our two events. We've got event 1 and we've got event 2. But there's no change in the particles. That's because there's no connection between these events. So what we're going to do now is we're going to create a test. And that test will actually pass the particles from one event to another. And I'm going to use an age test to do this. So I'm just going to drag this out here. And I've popped it at the end of the test. And as I said, I generally keep display operators at the end. So I'll just grab this, move it down, and drop it. And you can see it's reordered the operators within the event. You can do this freely. You know, you can just drag them around by doing this. And you can see it's created a test, and we've got some parameters for it. Now, I want to have this age test be based on the age of the particles. So the first parameter is correct. I want to check to see if the age is greater than a certain value. You can see you've got two options, is less than or is greater than. So is greater than is good for me. That's what I want to use, so I'll just leave that as it is. Subframe sampling, that will actually test the age of the particles between frames, not just on frame intervals. And it generally gives you much more accurate sort of age test, so it's best left on most of the time. But it can slow down your particle flow, so you don't necessarily have to use it, but it generally will produce a better quality particle flow. So we'll just leave that on for now. And we've got a test value, that's the age that will be tested, which is 30 frames. And we've got a variation of 5. Now, with a variation of 5, you're going to get 30 minus 5 to 30 plus 5 as a range within which this test will be true. And it's random for each particle. And you've got a little value here that actually determines how that random value is calculated. Now, as I said, that will give you a value between 25 and 35, and I don't really want that. I want it to be absolute. I just want a simple value, so I'm just going to zero that by right-clicking on the spinner, and I'm going to change this to 20. So now, when the particles reach 20 frames of age, they'll be true. The test will be true for them. And if we scrub through the timeline, don't forget the particles have been born over 20 frames, so they won't all reach that value at the same time. Sorry, they've been born over 30 frames, 0 to 30. So there's a different age range on all our particles. Some of the particles, well, when the last particles are emitted, the first particles will be 30 frames old. So there's a big range there when particles will pass from one event to the other. And if we scrub through the timeline, you can see we're still not getting anything. That's because we haven't wired the two events together yet. So, you can see each event has this little ring at the top, and that allows you to wire particles into it. And you can actually wire more than one event into another event. So we'll just grab the little nub again, and we'll hold it over the ring, and you can see it's produced the inward pointing arrow, so it shows that there's a valid connection. And we'll just leave go. And now what should happen is when this test becomes true for each particle, the particles will go out through the wire and appear in this next event. And most of the time they'll actually inherit nearly all of the parameters, the channels which have been set up for them. The speed data won't disappear, or the age won't disappear. It'll keep the same age and it'll keep the same speed. But in our case, we've actually got a different operator here. So what's going to happen is that when the particles go to the next event, we can change the speed of them. So let's change it to a very low speed so that becomes quite obvious. I'll just change that to 5. And now when I scrub the timeline, you can see that the particles flow down, and when some of them reach age 30, there you go, you can see they've actually changed shape, and they've changed color, and they've changed speed. So you can see now that the speed value set up by this operator is actually taking effect when they appear in the second event. So that's it. I mean, that's a very, very basic flow there. It's obviously very simple, and it's quite a simple test we're using at the moment, but this is the fundamental of particle flow, and this is where the flow actually comes from. So that's pretty cool. We've got a basic flow, and we've got particles flowing from event to event. So we're pretty much getting there now. Okay, so now that we're more familiar with the way the event view is used, let's go into a little bit more detail on how we navigate around it and how we use it, and how we can